Some ordered pairs are listed in the table at right. So over here we see our table of values here. The independent variable is in the first column and the dependent is in the second, which we've come to expect. So there's a number of things they're going to ask us to do here. We're going to create a scattergram. We're going to see if the variables x and y are linearly related, approximately linearly related, or neither. So we'll have to wait until we get our picture up to see which of those is going to be true. Then we're going to draw a line that comes close to the points in our scattergram, and we're going to see which point on our line has an x coordinate of 2. And then finally, we're going to be looking for x and y intercepts. So let's get our points plotted here. So remember that when we've got a list in a table like this, we can just think of the ordered pairs as just being written here. So as if we had a parenthesis there, a comma here, and a parenthesis here. So I'm going to scroll down just a little bit so we can see more of the graph. So negative 6, 8. So we're going to go negative 6 in the x direction and 8 in the y direction. And that's going to put us right about there. And then we're going to plot negative 3, 6. So there's negative 3 and 6. And then we'll do negative 1 and 5. Negative 1 and 5 is right there. 4 and 3, go 4 and then up 3. And then finally 7 and 1. So from the origin, go over 7 and up 1. Okay, so there we've created the scattergram of the points. Now we want to ask ourselves, does it look like they're linearly related, approximately linearly related, or neither? So linearly related would be that if we were to put a straight edge down on these points, we would see that they fall all exactly on the same line. Approximately linearly related would be that they're close to being on the same line, but there might be a few that kind of vary a little bit. And then neither would be that they really don't fall in a straight line. They're just kind of a random pattern, or maybe there's some kind of a curve or something like that if we were to connect them up. So with the way our dots are here, it's a little bit hard to tell if they're linearly related or only approximately linearly related. So what I'm going to do is I'm going to go ahead and grab a straight edge. So I'm going to bring a straight edge down. So here's my straight edge. And I'm going to move this straight edge and I'm going to bring it over here and I'm going to see what happens when I actually line it up. So I'm going to put one in there. And just like we would do as if this was on paper, and I'm going to tilt it. I'm going to kind of line it up because if it's linearly related, if I connect the first and the last point, all the points in between should fall exactly on that line. But we can see even though it's close, they don't quite all fall on that same line. So in that case, we can say that this is only approximately linearly related. They don't fall exactly on the same line. So now what I'm going to do is I'm going to go ahead and draw my line that comes close to those points. And I'm liking kind of how my straight edge is lined up right here. It kind of goes through the first and the last point. I have one point that's up above the line. I have 2 points that are just a smidge below the line. And so this is a good line that comes close. I wouldn't want all the points that fall off the line to all be above or all be below the line that I'm going to draw. I want to kind of find an average. I want to sort of split the difference for the ones that don't exactly fall on my line. So let's go ahead and draw our line here. So just like you would do if you were drawing on paper, and I'm going to extend it out beyond the points. I don't want to just start and stop at the points. I'm going to extend it beyond those points. So now we're done with our straight edge, so we can go ahead and make that go away. So just hold on a second while I do that. I'm going to drag it back over here and tell this to go away. And now I've got my line here. Now I do want to be sure to put arrows on my line to say this guy is going to be, this is a model that I'm saying is extending beyond. So I'm going to go ahead and put those arrows there. It goes beyond just the points that I plotted. Now we're going to figure out which point on our line has an x coordinate of 2. So let's see what's going on here. Here's my x-axis here, and my y-axis would be here. Be good to get those variables on there. They're saying it has an x coordinate of 2. So on my x-axis, I go to 2, and I'm saying, so where would this hit my graph? And so if I take that up to my graph here, and then say, okay, what y coordinate does that go with? it looks like it goes there to about 3.5. Okay, so it's somewhere between 3 and 4. So the point that has the x-coordinate of 2, well, the x-coordinate is 2, and we saw that we have a y-coordinate. We can either write it with 3.5 with decimal. We could also write it as 3, or sorry, as 2 and 3.5. We could also use the fraction form if we wanted to. And if you think you can estimate that more precisely, if you think that looks more like 1/3 or something like that, you can certainly do that. Our goal is just to estimate as carefully as we can. Now we're being asked to name x-intercept and the y-intercept of our line. So let's see where those are going to fall. Remember, the x-intercept is where my line crosses the x-axis, and the y-intercept is where my line crosses the y-axis. So since they're asking for both of those, let's be sure that we show which one is which. So the x-intercept is, and let's go over here and see where that line crosses that x-axis. So it looks like I'm going across, there's 8, and then it crosses somewhere between 8 and 9, and it looks like it's kind of right there, about halfway between. So I'm going to say that the x-intercept is, well, we have to name what that point is. Okay, so it's that point right there. So from the origin, we went in the x direction about 8.5 or 8.5. Again, you can use fractions or decimals, and if your instructor has a preference, be sure to pay attention to that. And then, so that's where I went in the x direction. Did I go anywhere in the y direction? Well, no, because if I'm on the x-axis, it doesn't make any sense to say that I would go up or down. So my y-coordinate is going to be 0. That's my x-intercept. For the y-intercept, we're going to use that same idea, but now we're going to go and look on the y-axis. So the y-intercept is, so let's see here. My line crosses the y-axis right about there. And so again, it doesn't fall on a nice tidy point. It's kind of somewhere between 4 and 5. And so I'm going to say that looks like it's at about 4.5. So we can say 4.5. Oh, but we have to be careful where that goes, right? I was just about to put that in the x position, which is not where we want that to be. Remember, to get to this point, where did we go? From the origin, did we go anywhere in the x direction in the horizontal? No. So we need to be sure that 0 goes in for the x value. And for the y, we go up to about 4.5. That's where we want that 4.5 to go. So notice that for a y-intercept, I'll always have a value for the y coordinate, and the x will always be 0. But for the x-intercept, I'll have a value in the x-coordinate, but the y will always be 0. And that's always going to be true. But again, if you just stop and think about it, it totally makes sense how that's all going to shake out.